Welcome back, dear children. Now we will move to section B, that is atmospheric pressure. Okay, in section A we were discussing about the liquid pressure. In section B we are going to study about the atmospheric pressure. So what is atmosphere? The gaseous envelope of air surrounding us can be called as atmosphere, isn't it? So what is atmospheric pressure? Pressure exerted by atmosphere. So the gaseous envelope of air surrounding us can be called as atmosphere, and the pressure exerted by atmosphere is known as atmospheric pressure. Now, the value of atmospheric pressure is 1.013 into 10 raised to 5 Pascal, or since this is a very small value, you can write it as 10 raised to 5 Pascal. So this is the value of atmospheric pressure at sea level. Atmospheric pressure is generally measured from sea level. Okay, so at sea level, value of atmospheric pressure is 1.013 into 10 raised to 5, or just you can say 10 raised to 5 Pascal. Is it clear? So this much pressure is there around us. Are we feeling it? 10 raised to 5 means it's a very huge value. But are we feeling this pressure? No. Isn't it? Here surrounding us we have air, and this much pressure is exerted by air on us. But we won't feel it. The reason is the blood and the other fluids present inside the body will balance this pressure from outside. Okay, so that is why we are not feeling this pressure. Is it clear? The pressure exerted by blood and other fluids in our body balances the enormous pressure from outside, and that is the reason why we are not feeling this pressure. Now, we have different other units and values when you consider the atmospheric pressure. So 76 centimeter of mercury in a barometer can be considered as the pressure at sea level. Then in torr, bar, etc. we'll be getting different values, but give importance to the value of pressure in SI system. That is 10 raised to 5 Pascal. Okay. Now in your textbook, it is given about the crushing tin can experiment. Last year also we learned that. It is not mentioned in the syllabus, so I am not moving to the crushing tin can experiment. And after that, we have many examples or applications of atmospheric pressure. We will consider the application. So, no need of crushing tin can experiment. Okay. So, about the applications, the first one, when you are drinking a juice using a straw. Actually, when you just put the straw in a juice glass, will the juice enter the straw? No, it won't enter, isn't it? So there what should you do first? First we will suck it. That is, we will suck the air present inside the straw. So when you are sucking, at first the juice won't enter the mouth. Air present inside the straw will enter our mouth. So when the entire air is removed from the straw by sucking, a low pressure region is created inside the straw. So nothing is there inside the straw, but outside we have the atmospheric pressure. So this atmospheric pressure will push the juice into the straw. Always there will be a push from a high pressure region to a low pressure region. Since no air is present inside the straw, there is a low pressure region inside the straw, and outside we have the atmospheric pressure 10 raised to 5 Pascal. So this atmospheric pressure will push the juice into the straw, and that is why you will be getting the juice through the straw. Now, same thing in the case of a filler. In the case of medicine dropper or ink filler, you are, in order to fill ink in the ink pens, you are having a filler, isn't it? Or in the case of medicines, giving medicines, a medicine dropper is there. In all these cases, when you just put the dropper or the filler into the ink or the medicine bottle, will the medicine or the ink enter into the filler or the dropper? No. If you simply put the medicine dropper in medicine, the medicine won't enter into it. So what should you do first? you have to press the upper part, isn't it? So you will be pressing. If it is a filler or a medicine dropper, first thing is to press the upper part. So when you press it, what happens? The air present inside the filler or the dropper will move out. So it creates a low pressure region inside the dropper or the filler, and the atmospheric pressure from outside will push the ink or the ink or the medicine into the filler or the dropper. Okay. Same thing in the case of syringe. To fill the syringe with the medicine, first the piston will be pulled back, isn't it? Have you seen? So first the piston of this syringe will be pulled back. When the piston is pulled back, what happens? Already air is present there, but when the piston is pulled back, more space is there. That means the pressure exerted, area is more, pressure inside will be less. So atmospheric pressure or the pressure from outside is more than that, and it pushes the medicine into the syringe. Okay. Now in the case of rubber suckers, what normally rubber suckers will be putting the rubber suckers on the walls or on the mirrors in order to hang small things, isn't it? So we'll just remove the tape and we will just put the sucker like this. Right? So when you're pressing like this, what happens? The air inside the sucker, the air between the wall and the sucker will move out and the sucker gets pasted there. It will remain as such. The reason is in the air between the sucker and the wall is moved out when you are pressing the sucker into the wall, and the pressure from outside will be exerting on the sucker and it keeps the sucker on in its place. Okay. Then another one is the siphon system. Have you seen the siphon system? There is two tanks will be there. One at a height from the second one. So if you want to take water from a tank here to this one, we'll be using a siphon system. Both contain water, and if you simply keep this tube like this, water from this tank A won't move to tank B. What you have to do? First, just suck the air present inside this tube. Then what happens? Naturally, the water will come to B. Okay. So this is known as a siphon system. If you want to move the water present in a greater height to a lower height, we will be using a siphon system. This is just a tube. Okay. A tube. So one end will be immersed in the first beaker, which is placed at a greater height, and the other end will be immersed in the second beaker. Now when you just put it like this, water won't pass through it. What you have to do is just suck the air present inside this. So suck the air means inside this nothing will be there. A low pressure region is created. So pressure, atmospheric pressure will push the water present in this cylinder to the siphon system. So water will come down and you can collect it at B. So these are the different consequences of what? Atmospheric pressure. Okay. Now, in your textbook, many things are given. One more example I can say what is given in your textbook. That is when you want to take oil from a sealed can or a packet. So when you are buying the oil and all, mainly this dalda and all, it will be, the packet will be sealed or that can will be sealed. That means inside that no air will be there. A sealed can or a sealed cover, oil covers and all, if it is sealed means no air will be there. So if you just make a small hole on it, oil won't come out. The reason is the pressure exerted by the atmosphere won't allow the oil to come out of the can or the packet if you make a small hole on it, because a sealed can or a bottle or a tin means inside that no air is there. Okay, so the actual push will be from the air outside. So the oil present in the can can't come out. In those cases, normally what we will do is we'll just make another hole on the opposite side of this can or the sealed tin, so that the air, some air will enter into the can. Since it is sealed, nothing will be present there. Okay. So when you make a hole on the other side, air will enter into this can so that it can balance the atmospheric pressure exerted from outside and you can take oil from the can. Okay, so already I told you we don't want the crushing tin can experiment, but you have to consider the consequences of atmospheric pressure. And the next topic is about the measurement of atmospheric pressure. This is also not there in our syllabus. Okay, so but you should know one thing. How can you measure atmospheric pressure? Which instrument is used in order to measure atmospheric pressure? It is a barometer. Okay, so only that you should know. Barometer is the instrument used in order to measure atmospheric pressure. So three different types of barometers are explained. Its construction and working are explained in your textbook. It is not needed. Okay, that is from page number 96. You can see measurement of atmospheric pressure. So that part, entire part is not needed. Okay, till page number 99. Till this portion, it is not there in the syllabus. Measurement of atmospheric pressure is not there in our syllabus. So you should just know barometer is used in order to measure the atmospheric pressure. Then you can take page number 99. In that, variation of atmospheric pressure with altitude is important. Okay, so what is altitude? Height. What happens to atmospheric pressure when height increases? Already we know that pressure increases with depth and decreases with height. That is the basic thing what you have to remember. We will be considering all the measurements at sea level. When you are moving down, pressure increases, and when we are moving up, pressure decreases. Now, why the pressure decreases when we go up? Or when altitude or height increases, why does the atmospheric pressure decrease? So two reasons are given there. First one is the decrease in the height of the air column. Second one is the decrease in the density of the air column. Here we are having more than enough air, but when you are moving up, the height of the air column as well as the density of the air column decreases. Already we learned an equation for pressure, fluid pressure. What is that? HdG. Pressure depends on height and density. So when we are moving up, what happens? There is a change in the height, isn't it? Then about the density, height of the air column. Height of the air column decreases as well as the density of the air column decreases. And this is the reason why pressure decreases. Okay, so this box is important. Please mark that. Okay, variation in atmospheric pressure with altitude. When altitude or height increases, atmospheric pressure decreases. The reason is decrease in height of the air column and decrease in density of the air when we move up. And this can be represented using a graph. Okay, so we are considering taking atmospheric pressure along y-axis and the altitude or height along the x-axis. And when you draw the graph will be like this. Okay, so please consider this graph. So when height increases, pressure decreases. Okay, it will be going down and it touches here. This is the shape of the graph. So please consider this graph also with height. A graph showing the variation in atmospheric pressure with altitude. When altitude or height increases, pressure decreases. Okay, now two consequences are of this decrease in the atmospheric pressure is explained in your textbook. First one is in the case of nose bleeding. When you are moving to a greater height, nose bleeding will take place. So what is the reason? When actually I told you we have enormous pressure surrounding us, but the pressure exerted by the blood and the other fluids help us to withstand this pressure from outside. Now when you are moving to a greater height, what happens? There the atmospheric pressure is less. The pressure from outside is less, but the pressure exerted by blood and other fluids remain as such. So since the pressure inside, blood pressure exerted by blood and other fluids inside the body are more, what happens? Nose bleeding. The veins will break and nose bleeding occur. And when you take a fountain pen to a greater altitude, the ink will leak out. This is also the same thing. The ink can't stay there because the pressure exerted from the outer part is less. So the pressure is more inside and it makes the ink to leak. Okay. So these are just two consequences. Now the next part is needed. This barometer is used in order to measure atmospheric pressure, and by measuring atmospheric pressure, with the help of the measurement of atmospheric pressure, we can forecast weather. Okay. So pressure, atmospheric pressure can be used. Using the value of atmospheric pressure, weather forecasting can be done. So normally in a barometer, if you are considering a simple barometer, there a test tube will be there, and at sea level, and inside the test tube you will be having mercury. Okay. If you consider a simple barometer, it consists of a test tube with mercury in it, and when you keep this at sea level, the level of mercury will be 76 centimeter. And when you are moving, when you are taking it to a greater height, what happens? The value of atmospheric pressure decreases. Okay. So at sea level, 76 centimeter will be the reading shown by a simple barometer. Now using the reading shown by a barometer, we can forecast weather. Okay. Weather forecasting can be done using this. So first, where at sea level, the reading shown will be 76 centimeter of mercury, and if the reading shown in the barometer drops suddenly, okay, so if it suddenly falls, that means there is a chance for cyclone. Okay, if the reading suddenly falls, then if it gradually falls, there is a chance for, if it gradually falls, there is a chance for rain. Then if it increases slowly, then dry weather. Or if a rapid change is there, then it shows extremely dry weather. Okay. Extremely dry weather. And if there is no change in the reading of the barometer, that means the climate, there is no change in the climate. It will remain as such. Okay. So actually when you are considering a barometer, it can be used in order to measure the atmospheric pressure. By getting the reading of atmospheric pressure, we can forecast weather. So I told you at sea level, 76 centimeter will be the level of mercury in a simple barometer. Now, if the level of the mercury in the barometer suddenly falls at a place, it means that there is a chance for cyclone. If it gradually falls, slowly if it is falling, then there is a chance of rain. If the value increases slowly, dry weather. Then if it is increasing suddenly, then it is extremely dry weather. If there is no change, means the climate will remain as such. Okay. That is, weather will remain unchanged. Then the last one is about an altimeter. Do you know what is an altimeter? Altitude is height. Altimeter is an instrument which is used in order to measure the height. Okay. Altimeter is used in order to measure the height. So Depending upon the atmospheric pressure or using a barometer, you can measure altitude also. Okay, so for every 25 centimeter rise, or there is a particular value for a particular height, increase in height, the reading of the atmospheric pressure falls to a certain extent. So using this concept, altitude can be measured using a barometer. That means a barometer can be used as an altimeter also. Okay, so once again, for every small change or increase in height, there will be a decrease in the atmospheric pressure, and keeping this in mind, we can measure the altitude. Okay, so is it clear? In this section, we just discussed about atmospheric pressure, then consequences of atmospheric pressure. After that, measurement. You should only consider that a barometer is used in order to measure the atmospheric pressure. Barometer is used in order to measure the atmospheric pressure. No need for the construction and working of the barometer because measurement is not there in our syllabus. Then you have to consider the variation of atmospheric pressure with altitude. Two reasons: decrease in the density of air and decrease in the height of the air column. Then we considered the graph. After that, two more uses of measuring atmospheric pressure or barometer, you can say. First one is about the weather forecasting. So using the reading shown by a barometer, you can forecast weather. Now the last one is a barometer can be used as an altimeter, because for every rise in height or increase in height, there is a change or decrease in the atmospheric pressure. So keeping this, we can measure the altitude. Okay, so no need to go in deep about that. Just you should know what are the uses. Clear? So here also the entire portion is not needed. I'll just tell you which all question answers you have to write. Please take page number 101. Page number 101. Question number 1, 2, 5, 7, 11, then 27, 28, 29, 30, 31 and 32. I'll repeat. Page number 101, exercise 4B, question number 1, 2, 5, 11, 27, 28, 29, 30, 31, 32. So only this is needed from the chapter. Okay. So we have completed this chapter. Actually, it is a very big chapter, but many things are removed. Okay, it is not there in the syllabus. That is why we completed the chapter within one or within two, with the two videos. Okay, so write the question answers, write the lecture note, study the portions and be ready for the Google Meet. So is it clear, children? Thank you.